How's it going, guys? Today we're going to be going over another LeetCode question. Today our question is called Bag of Tokens, and this is a question that's currently being asked by Google right now. Alright guys, so today our question is called Bag of Tokens. Again, this is a question that's being asked by Google right now. And our problem description says, you have an initial power P, an initial score of 0 points, and a bag of tokens. Each token can be used at most once and has value token I. And it's potentially two ways to use it. So the first way we could use a token is if we have at least token I power, we may play the token face up, losing token I power and gaining 1 point. If we have at least 1 point, we may play the token face down, gaining token I power and losing 1 point. And they're basically asking us to return the largest number of points we can have after playing any number of tokens. Okay, so we're given a bag of tokens. We have an initial power P, and we have 0 points to begin with. We're asked, based on these two different choices that we have for each specific token that we get, what's the maximum number of points that we could have at any point during our game? And again, for each of the tokens, we have two different options. The first option is we can either trade in X amount of power and get 1 point, or we can basically give in a point and get back X amount of power. And we're basically just asked throughout this whole game, like what's the maximum number of points we could have at any given time, basically. So that doesn't really make sense. That's totally fine. I feel like this problem description is pretty weird to begin with. So we'll go through our examples. So if we were given a bag of tokens that just had a token with value 100 in it, and power was initially 50, we'd output 0, right? Because we can't actually get any points. We start with 0 points, and we don't have enough power to give in to get that token, or to get a point for getting that token, right? So we can't do anything, and we have no points to begin with, so we'd output 0. Not very interesting. So now if we move to example 2, if the tokens we were given were 100 and 200, and our power was 150, we can actually get 1 point, right? And the way we'd get that 1 point is we would trade in 100 power, right, for this token, and we get 1 point. Then we'd have 50 power left, and we could, in theory, give in our point, right, to get back 200 power, but we're trying to maximize our points. That doesn't really help us, so we'd return 1. Now, this is a little bit more of an interesting example here. In example 3, if we were given tokens 100, 200, 300, and 400, and our power was 200, we would output 2. And the reason for that here is because we would trade in 100 power for this token, and we get 1 point. And then we'd have 100 power left, but we have 1 point, right? So what we could actually do here is we could trade in our 1 point for 400 power now. So now we have 500 power. And now we could actually buy basically these two tokens, because that adds to 500, and we get 2 points back. So our maximum amount of points would be 2. And then just as a couple notes here, we're told that the token's length is always less than 1,000. We're told that any value of a token is always between 0 and 10,000 inclusive. And we're told that our initial starting value of P, or power, is always between 0 and 10,000 inclusive as well. So there's a couple things that we want to think about, right? The first thing we want to think about is we want to maximize our points. That's what we really care about in this problem. So now that we know we want to maximize our points, we have to pay attention to how we can get a point. And there's only one way to get a point in this problem, and that's basically by giving in X amount of power for a specific token, right? So if token I has 10 power, and I want to get that token, if I have 10 power, I can give in 10 power to get a point. I guess like by purchasing that token, that detail doesn't really matter. But if I give in that amount of power, I get a point for that token. Great, so what does that tell us? It tells us that we want to maximize the number of points. So I always ideally want to give in the least amount of power, so that I always have power, or as much power left over as possible. So I always want to get a point by giving in the least amount of power, which means I always want to know the lowest token that I could potentially trade that power in for. So that's the first thing, right? So that tells me that I want to know always the least amount, or the smallest token that I could deal with at any given time. And so that's a really good indication that I want to sort my array. So that's the first tip. The second thing that I want to know is that anytime I actually do not have the chance to gain a token, right? So if I don't have enough power, I don't have the opportunity to gain a point, right? Because I don't have enough power, I have one other option, and that is to give in one of my points in return for power if I have points. So that also tells me that anytime I give in a point, right, to get power returned to me, I want to make sure that I'm maximizing the amount of power I get. So again, that's another really great reason why I want to sort my array, because I'll basically know that my lowest value is always at the beginning of my array, right? So anytime I trade in to get a point, I want to make sure I'm dealing with that token. And then anytime that I don't have enough power to get a point, but I do have points, sorry, I don't have enough power to trade in for a point, but I do have enough points to trade in for more power. I want to make sure that I'm getting the largest token so that I get the most amount of power. So that might be a little bit confusing. I think the logic will be a lot more clear once we get the code down here. But the first thing we just said we want to do is sort our array, so we always know the smallest and the largest token at any given value, or any given point in our game, basically. So we're going to say arrays.sort for tokens. And now what we want to do is we want to declare basically two different variables. One that we're going to return, which will just be the maximum number of points that we can get throughout our entire game. And then another one tracking the number of points that we have basically as we play. So we're going to say int max points equals 0, and then int points equals 0 as well. Now we need the pointers, right? We need to know where the smallest token is and where the largest token is, so that can just be done by our pointer. So int I equals 0, and that's again because we just sorted our tokens, so the 0th token will be the smallest. And int j equals tokens.length minus 1, and again that's because the largest token will be at the back of our array to begin with. So now I could say, well, I is less than or equal to j. That means I haven't gone through all the tokens, so I could basically simulate playing while I haven't reached, right? While the two pointers haven't touched, or really crossed in this case, we want to keep playing our game. And so we want to maximize our points, right? So any single time that I can get a point, I want to make sure that I take the opportunity to do so. So the only time I can get a point is if I have enough power, right? So if my power is greater than or equal to tokens of I, and again it's going to be tokens I because I is always going to represent the smallest token that we have access to at any given moment. So if I have enough power, great, then I can get a point. So we'll say points plus plus. Then we'll also decrease our power, right, because we have to trade in our power by that amount. So we'll say power minus equals tokens of I, and I'll just say plus plus here so that the next time we know that we've already used that token, and the problem tells us we can only use tokens once. Now, the next thing I want to do is basically update the maximum number of points that I've ever had, right? So if this is a new maximum amount of points, I want to make sure that I store that. So I can say max points equals math.max, but whatever max points is currently, and whatever points is currently. Great. So now, let's say I don't have enough power to actually get a point on whichever token I'm on. Well, the only other case that I can try and do that's helpful is if I actually have points, then I can simulate giving in a point and getting back the maximum amount of power. So let's think about that logic now. So otherwise, if I have points, right, so if my points are greater than 0, then that means that I should try giving in a point and getting the maximum amount of power. So the first thing I need to do is give in that point. So I say points minus minus. Then I need to actually increase my power by however much power I'm going to get back, right? And I always want to take the maximum amount of power to make sure that I'm getting the most bang for my buck, or the most bang for my point here. So we're going to increase our power by tokens of j, and we're going to say minus minus, so that again, we're not going into the case where we're reusing tokens multiple times. Great. So now, if I can't get a point because I don't have enough power, and I don't have enough points to actually try and get more power, that's basically it, right? The problem's over. So I could just return my maximum number of points that I can get, or that I've seen throughout the game that I've played. And similarly, if we actually go through simulating, dealing with all these different tokens, whenever this loop ends, we'll also want to return our maximum number of points. So now let's just run through and talk through our runtime. So our runtime here is going to be n log n, and the reason for that is this overhead that we're getting from sorting the tokens. So we could say that our runtime is n log n, where n is the number of tokens that we're given. In terms of our space complexity, we're just declaring a few variables, right? So that's going to be constant space or O of 1 space. So I say the runtime here is n log n due to the overhead of sorting the tokens. Then I'd say our space complexity is constant or O of 1. So let's run this. Let's make sure that it works. Awesome, and it does. So guys, that's how to solve bag of tokens in Java. Again, it's a question that's being asked by Google right now. If you guys enjoyed this video and found it helpful, do me a favor and leave the video a like and subscribe to the channel for more. I'll see you guys next time.